Thank you.
I was reading to the kids and I heard a thump.
And I was sitting right here, like right here.
And I thought, was there a car crash?
And it landed right there.
Oh my gosh.
Inches, within inches of me.
It looked like a bomb went off in here.
I would compare it to a 12 gauge or a little louder.
The big hole in the roof, it's like, where in the world did that come from?
It was that quick. It was like, boom, it was done.
One Elk Mound man had a bit of a rude wake-up call this morning after this ball of ice crashed through his bedroom ceiling.
12.6.
It weighing in at a whopping 12.6 pounds.
And it hit you.
It grazed me. As soon as that come through, everything else was like a dust of insulation, and I couldn't see.
12 pounds of ice causing thousands in damage.
There's more than $1,000 worth of damage up there.
Here is one of the support beams.
Come out.
What's left of it.
Yeah.
The big question left on everyone's mind is, where did it come from?
Because there was a big black cloud above it, and of course we just had the storms this morning.
Officials from the National Weather Service office in Chanhassen, Minnesota, said this morning's storms weren't strong enough to cause any hail that big.
It'd be neat to see what it analyzes at, the contents of the ice ball, and figure out possibly where it came from.
All I know is God had to been watching out for me, because I could have died.
Yeah.
I could have. And it landed right there.
Oh my gosh.
Inches, within inches of me.
Back in late May, a 12-pound chunk of ice came crashing through Ken Millerman's Elk Mound bedroom ceiling, causing thousands of dollars in damage.
It looked like a bomb went off in here.
But the question still remains, what is it? UW-Eau Claire scientists are eager to figure it out.
We think it's likely to be a megacryometeor, but
Wait, it's a what?
these have been observed around the world, maybe to the tune of maybe dozens per year, a dozen or so per year, that have been documented.
Okay, but what is a megacryometeor?
Well, that's a really good question.
That's exactly what students and staff at UWEC's chemistry department set to find out.
So while some people suggest that megacryometeors really just come from airplanes, some people say, oh, well, it's the head or the bathroom in the airplane, or maybe it's coming out of the wheel well. That explanation doesn't hold up if we have samples back into the 1700s.
So maybe it's from space?
So other people suggested, maybe there's extraterrestrial in origin, it was a comet or something like that. And I think the likelihood of that is very low, but we have tests that we can do to ascertain that.
If it's not from space and it didn't come from a plane,
The last possibility, and maybe the most mysterious, is that it has a natural origin in the upper atmosphere.
the way Dr. James Bolter described their theory to me of how this ice formed looks a little something like this. The bottom layer of the atmosphere we live in is called the troposphere. The layer above that is called the stratosphere. And in between those two is a thin boundary about 9 miles off the ground called the tropopause. Certain jet stream dynamics can sometimes cause what is a fold in the tropopause, which allows the warmer, drier air from the stratosphere to enter into the troposphere. Again, it's just a theory, but it suggests ice particles can form rapidly in these conditions, causing large blocks of ice to form. Gravity allows them to fall, and in this instance, make it to the ground.
The conditions to create something of this magnitude up there had to be pretty interesting. With a dozen or so of these things a year, just the ones that have been reported, right? Imagine all the ones that fall over oceans or forests. So yeah, there's probably a lot more of these than we actually know about.
A rare research opportunity, to say the least.
The actual ice chunk itself is highly contaminated, so we'll actually be coring into it to get at intact ice. So we can do these individual analysis, looking at metals, looking at organics, looking at isotopes, to conclusively rule out, is it from an airplane? Is it from outer space?
And we got some really interesting results. But I think the first and foremost result is it's clear that it's not a poop ball leaking out of a bathroom on an airplane.
Back in May, this 12-pound chunk of ice crashed through Ken Millerman's bedroom ceiling.
And it hit you.
It grazed me.
Once the dust settled, UWEC chemists took what they are calling a megacryometeor back to the lab with a lot of questions.
But the big mystery is how in the world did it get to be this big so that it eventually fell into this gentleman's bedroom?
So Dr. James Bolter and his team tried to answer instead, what is this megacryometeor made of?
So I was responsible for looking at the biological part of this to see what might be in that ice ball that would be interesting, either alive or maybe preserved.
Maybe this would help us understand where it came from.
We found a really interesting array of microorganisms. Some of them were the so-called blue-green bacteria. Some of them live in Antarctica. They can live in deserts. They've even taken them to outer space. That's how tough these organisms are.
We also saw very low concentrations of metals. The metals we did see were metals like sodium and iron and calcium.
So how do all of these things get into the atmosphere in the first place?
Right, so if we think about the way that ice is formed in the atmosphere, it starts out at the surface, either evaporation of ocean water or fresh water, but a lot of times it has at its nucleus, the center of these little droplets of water or particles of ice, we're going to have a little speck of dust.
That dust may be carried into the higher levels of the atmosphere by strong windstorms at the surface. Dust storms from places like the African deserts, volcanic eruptions in Spain, or even the wildfire smoke from out west. They all eject particles up into the atmosphere.
That's a good description of how droplets form in the atmosphere. Any of those processes form this little chunk of matter onto which the water can condense to form a raindrop or a snowflake or an ice particle. It's hard to know because it's still mysterious in that respect.
But there is one thing Dr. Bolter can say with almost 100% certainty.
The highest concentration metals we measured were sort of in their tens of parts per million. And so that means probably 99.99 at least percent water. That's pretty clean.
And this is probably one of those once-in-a-lifetime opportunities, would you say?
Hopefully.
Hopefully for his and Ken Millerman's sake.